really tough, I think, to me.
Maybe, but you have to put only precise justification, not full proof or anything. You have to just write the key points of the line. Means what is the main point? If you have any counter example, just 2-3 points. Otherwise, you have proof. Then maybe a little bit very lengthy, and it's always professor's paper is always lengthy. Easy, but it's always lengthy.
Yes, it's but sometimes it is too lengthy that sometimes I do some mistakes and
Yeah, maybe in hurry you have calculation mistakes or.
yes, those are happening for
Okay,
me.
I will communicate to him about this, that students saying that paper is too lengthy, or maybe in next exams increase the time or short the paper.
That will be better for us.
Yeah. Okay, so let me share my screen and yes, my screen is visible.
Yes, it's visible.
So I think questions were easy, but just for clarification, once we discuss all the questions. So for question number 1, how you have done this question number 1? Yes. So ma'am.
Sorry, I have not done that.
Okay, and anyone who is here? Okay, let me tell, this one is actually a good question. You have to know. So just let me give you a hint for this. It's a linear transformation from R3 to R3. This means the matrix of T is will be of the mark 3 cross 3. So this implies the characteristic polynomial be of 3 degree, and this implies characteristic polynomial has one real root. This whole argument will implies that T has a real eigenvalue. Is it okay? Now here, okay. So let lambda be the real eigenvalue and V is the eigenvector corresponding to lambda. Now we claim that W is the span of V is T invariant subspace of R3 of one dimension. So it is eigenvector, so V obviously non-zero by definition of eigenvector. So W is one dimensional vector subspace. Now we have to show that T of W is subset of W. So if you take any small w, TW, it is of the form KV. KV is some scalar because W belongs to W, then and W is spanned by V. So we have W is of the form KV. So we can take scalar outside, T of V, and T of V is lambda V. Because it is eigenvalue, this means this implies T of V equals to lambda V, and V non equals to 0. So this is again a scalar. So and is V, and this W is span. This implies this belongs to W. So this means TW belongs to W. This implies W is a T invariant subspace. Is it clear?
Yes, it's clear.
Okay. Good. Now how we will do second question?
A second question actually, skew-symmetry matrix of odd order determinant value will be always 0, and so it will not be invertible. But what about if the matrix is over a complex number?
Okay, maybe over complex number. If it is on Hermitian, you mean skew Hermitian?
Yes.
Yeah, same thing. For skew Hermitian, you also have order, means you, how you know that skew symmetric matrix determinant A is equal to 0. For skew symmetric means A transpose equals to minus A. For Hermitian, you know that this eigenvalues thing, either imaginary or 0. As it is of odd order, so it can't have all the eigenvalues imaginary, because imaginary or complex valued eigenvalues occur in pair. So it has odd order, so it must have 1 0 eigenvalue.
Yes, yes.
So this implies determinant of skew symmetric matrix or skew Hermitian matrix is of order is 0. This implies it cannot be invertible. So I have given hint for second question. If anyone has any doubt or need any other explanation, please ask. Yes. Anyone? Arvis, Dabra, is it clear to you?
Yes, sir. Like we use like the order of in an odd ordered symmetric matrix, the determinant is always 0. Like we can easily prove it.
Yes, yes. You may prove or you may just state that thing with some.
Yes, sir. Like
Because
we
it's
just
1 mark question.
I just mentioned it that it's a 3x3 matrix, a symmetric matrix, so its determinant 0 being a ordered odd matrix. That's why.
Yes. So is it clear to all? Manish and Rumik, is it clear? Question 2 is easy. Okay, for question number 3. Yes, anyone?
So I took it to be the rotational matrix with angle 2 pi by 3. So by its properties, A cube is identity and A itself is not identity. That cos 2 pi by 3 minus sin 2 pi by 3, sin 2 pi by 3, cos 2 pi by 3.
Means you have taken this matrix cos 2 pi by 3 sin
Minus
2
sin 2 pi by 3.
Okay, sin 2 pi
Sin
by
2 pi by 3, cos 2 pi by 3.
Okay, this one is it. So A cube is identity. Are you sure?
Yes, sir.
Means you have to done calculation. I haven't done this one.
Actually, sir, the whenever we define the rotational matrix, it's the rotation by 2 pi by 3. So thrice the rotation will be the identity matrix.
Okay, so no problem. Okay. Anyone else trying with how to get a matrix for counter example? Yeah, obviously you get an example, so it must be false. Actually, there is no two class matrix such that this will happen. Means there may be an matrix A such that A cube equals to I, but A need not be I, identity matrix. So anyone else how to solve this or how to get counter example or prove this statement approach?
I have taken a matrix that -1, -1, 1, 0, and that would satisfy this. But A is not equal to.
Okay. Yes, this correct. Okay. Anyone else? I mean, how you get this example? Means any idea, any intuition, how you reach to that example? Anyone? So whenever you get such a type of question, you have to just remember one thing. If this is condition, what does it mean? This means x cube minus 1, if we say fx a polynomial, it is annihilating polynomial for A. And we know one theory that minimal polynomial divides annihilating polynomial. So if minimal polynomial is px, then it must divide x cube minus 1. This means px divides x minus 1, x square plus x plus 1. So this means px possibility of px is x minus 1 or px equals to x square plus x plus 1. And it is of 2 cross 2 arm. So it cannot be both multiplication, means it is not of 3 cross 3 degree. Px cannot be of 3 degree polynomial. So when px will be this implies A equals to identity, but there is one possibility also. If px is this one, then A need not be identity. So for this one, you get this matrix that he already told. Is it correct? Yes. So for this minimal polynomial, so for this minimal polynomial, you have to construct a matrix, and that will be the counter example. And this is one approach you can reach to an example, or if you want to prove, then you can reach up to here. Is it clear?
We need to show all of these things. Actually, I have just write the matrix and shown that A cube is equal to I, but A not equal to I.
Yeah, this is correct, no problem. If you given the counter example matrix, for little bit more explanation, you can show that A equals to this matrix, some matrix which is not equal to identity, and just so A cube equals to I. So this one is counter example. That's it. Just I'm saying, if you just suppose you have to prove this one, if it is true, then how you can approach through minimal polynomial and statistic polynomial and letting polynomials. These are the correct way or approach you, and if you want to prove or disprove. If you, this one is simple expression, so you get the matrix. If it is 4 cross 4 or 5 cross 5 or any other order, then it will, I think, difficult to construct direct examples. Is it okay now?
Yes, sir.
Yeah. Now for question number 4. Yes, Rumit goes. Have you done question number 4?
Taking at lambda equal to 0, you can show that lambda will be an eigenvalue of BA, and if lambda not equal to 0, then we can show by that the relation that ABX equal to lambda x, and then by multiplying B, and so.
Yes, it is correct. So just one thing in this question, maybe someone may wrong the way. Just assume that lambda be eigenvalue of AB. So what does it mean? There exists an x not equal to 0 such that AB x equals to lambda x. So just multiply both sides B, matrix B, BA, BX equal to lambda. It becomes BX. B square will come out because lambda is a scalar value. So this implies BA Bx equals to lambda Bx. If you take Bx equals to y, then we get Bay equals to lambda y. So there is only one problem. What is the condition when y is not equal? When y is not equal to 0, this implies lambda is eigenvalue of Ba also when lambda is eigenvalue of Ab. The condition is when y is equals to 0. Then what will happen? This implies Bx equals to 0 for x not equal to 0. This implies 0 is eigenvalue of B. You can approach this way. One, if you get 0 is eigenvalue of B, this implies determinant of, okay, let me write it to be clear here. For the case when Bx equals to 0, this means Vx equals to 0 for x not equal to 0. This implies lambda equals to 0 is eigenvalue of B. This implies determinant of AB equals to determinants of A and determinant of B. This equal to 0. This implies determinant of B into determinant of A equals to 0, and this implies determinant of BA equals to 0. And this means BA has at least one 0 eigenvalue. So this implies if here means Bx y equals to 0, this implies AB has determinant of AB equals to 0 means AB has 0 eigenvalue, and this implies BA has 0 eigenvalue. So for 0, when lambda is 0, then AB and BA both have 0 eigenvalue, and if lambda is non-zero, then you can prove that yes, for this lambda, if for AB you get x as an eigenvector, then for BA you will get Bx, that is, let's say y as an eigenvector for lambda. So the eigenvalues are same, but eigenvector are different. Okay, is it clear up to here? Arviz, is it clear?
Yes, sir, it's clear. Yeah.
Okay. Now question number 5. One is little bit, maybe that question is lengthy first, but I haven't solved this question actually, but it was easy. You have to find the, let's assume that A equals to, if you take 1 1 1 1 1 1 1 1 1, then just you have to find A minus lambda I determinant equals to 0. So what will be it? It's something like 1 minus lambda 1 1.
And so it will be lambda square 3 minus lambda. The x square 3 minus x, the characteristic polynomial.
X square x minus 3.
3 minus x. 3 minus x or x minus
Okay,
3.
okay.
3 minus x actually.
Yes, yes, got it. X square. Oh, again that. 3 minus x. So this one is characteristic polynomial. So you have to check means minimal polynomial possibility of minimal polynomial is x 3 minus x or x square 3 minus x. So you have to check that a lambda. Oh, sorry. Here you put 3 lambda I. Sorry, I lambda I am writing here. 3I minus a is 0 or a square 3I minus a equal to 0. If this will be 0, then this will become a minimal polynomial. If this will not 0, then this become minimal polynomial. So you have to just only multiply this matrix, check 1, and if not this one 0, then this automatically become minimal polynomial for this. And you have to calculate the characteristic polynomial by multiplying or any means you know how to calculate minus x and put all that thing. Okay, so this one is only calculative part.
And sir, isn't there any direct way to find the minimal polynomial? Like this way, it's a very lengthy question. Like if we see this is a question of 1
You
marks.
have only two multiplication, one multiplication and one to calculate the.
I just wanted to ask you whether there's a direct way to find a minimal polynomial for some question for a matrix, or this is the only way.
No, without any other information, if you have given exact means matrix, then you have to calculate this characteristic polynomial, then minimal polynomial. In above case that I suggest, if you get any relation like this, then you can show that okay, this one is x cube minus 1 is inletting polynomial for a, so minimal polynomial must divide this.
So yes, the same arguments.
Yes, so that may be a little bit easy for some cases. Otherwise, you have to calculate in this way. And this one is a similar one. This one may be a little bit more lengthy, I think, because you have to find the roots. So if characteristic polynomial become easy, then you can find easily. Otherwise, it will be difficult. So there is.
Yes, it's in my case it's become a weird type of 3-degree equation though. So how can I solve by?
Yes, this one was actually the lengthy. Maybe for someone, if you get 0 0, then it is become easy. Otherwise, if you get 5 7, then it will become a little bit more lengthy.
Yes.
Okay, if some of you, I mean, try and find at least characteristic equation, then maybe partial marking half, and if you find some eigenvalues in complex form, then simplify, then marks will be given for that. No problem. It was actually lengthy. This one is actually lengthy problem. Okay, now for question number 6, how you have done? So the key point is that
taking the transformation as
yes.
Taking the transformation as from, like, if we take the elements of B1 to B1, B2, B3, and B2 to B1, W2, W3, then the transformation S will be V1 map to W1, V2 map to W2, and V3 map to W3, and then the matrix of this transformation with respect to B1. This will be the change of basis.
Yes, I have seen this one. Just anyone if find anything else in books or anywhere, let me know. The meaning of this one, this statement, the line language. This means you have to find the transformation from B2 to B1, not B1 to B2. This one is wrong. Okay. If anyone find any literature or book like this, I have seen. I know what I. So if anyone find anything other than this one, so please let me know. Okay. For this one, the change of matrix from B1 to B2 means we have to write the basis elements of B2 in the linear combination of B1. So you have to write actually V1, W1 is at alpha 1 1, V1 alpha 2 1, V2 alpha 2 3. So let me write alpha 3 1 V3, and W2 equals to again alpha 1 to V1 plus alpha 2 to V2 plus alpha 3 to V3, and W3 equal to alpha 1 3 V1 plus alpha 2 3 V3 plus alpha 3 3 V3. Here it is B2. So in some books they have taken this matrix, what we get alpha 1 1 alpha 2 1 alpha 3 1 alpha 1 2 alpha 2 2 alpha 3 2 and alpha 1 3 alpha 2 3 alpha 3 3. So if you taking means if you define a transformation like XA, if you multiply a vector X to matrix A as XA, then this will be the matrix, and if you multiply AX, then you have to take transpose of this matrix. So these two are correct for this question. Yes, anyone has any doubt or anything? Is it okay for everyone? So just note that, I repeat once more, that you have to find the elements of basis of B2 in the linear combination of B1, not B1 up to B2. Yes, if anyone, any comment or anything?
No, it's okay. I did the ulta.
Okay. Yeah, maybe I was actually solving first time, then I also get a little bit confused. So if please see in books or anywhere, maybe some just like this matrix, maybe some books have different notation. So I found somewhere that this one is means you have to write B2 to B1. So if anyone has written B1 to B2, you mean you have read somewhere or anywhere. So if you find anyone, please let me know. Otherwise, whatever I know, this one is correct. If from B1 to B2 means you have to write B2 in the linear combination of B1. Okay. Now for the question number 6, 7. Sorry. Yes, how you have done this one? Anyone?
There will be two defined eigenvalue and corresponding to defined eigenvalue, you will have two defined eigenvector, linearly independent eigenvector, and for R square to linearly independent vector generate R square and also forms a basis. So
yeah, that's means you can get lambda 1 plus lambda 2 equals to 1 and lambda 1 into lambda 2 equals to minus 6. This is implied lambda 1 equals to 2, lambda 2 equals to minus 3. Means you are getting eigenvalues are different. So you have to, but note that you have to state the results. That means for distinct eigenvalue we get for two distinct eigenvalues we have linearly independent eigenvectors. And one more thing, R2 over R has dimension 2. This implies that any two Li vectors will span R2. So this means these two V1, V2, let's say corresponding eigenvectors for lambda 1 and lambda 2, they will generate or span R2. That's it. This is the argument you have to written, right? And this is obviously easy question. Now for
so the eigenvalues will be 3 and minus 2, right?
Yeah, maybe just okay. 3 and minus 2.
yeah, it will be 3 and minus 2.
Yes. Otherwise, this will become minus 1. Yeah, correct. Minus 2 and 3, and then you have to write this argument. Means here it is not important that 2 or 3. The concept is main that this lambda 1 and lambda 2 are different. That's the main key point. You have to get this one. So, and this one is easy equation. You can easily get that lambda 1 is minus 2 and lambda 2 is 3. So, not any lengthy process to calculate the lambda's value. Okay. Now for question number 8. Yes, how to approach this question? Yes, anyone? Anyone have tried this question or not?
We assume some alpha, 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 alpha as identity, and we show that it can't be any alpha, can't be identity.
Again, let me know. Means this has been given field, is it?
Yes,
So
sir.
you don't have to
So I
prove that it
think
is field or not. It is it is given that it is field. You have to check vector space property.
Yes, sir. We assume some matrix of all alphas to be an identity, and we take we see that
Okay, this
for
is
any
for
element in V, it satisfies or not, and we show that it can't be.
okay. You have shown that 1f into V is not equal to V. Is it?
Yes, sir.
Yeah, it's correct. So for precise, you can check, or it is easy to to check. It means you take any element a and take alpha 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 equal to a means you to get the identity element, that is a means and field element. What is the identity element? Then you compute this one, you will get alpha equal to 1 by 2. Means identity element of for this is 1 by 2, 1 by 2, 1 by 2, 1 by 2. So if you take any element of V means of the form ABCD, then you multiply, you will not get obviously ABCD. This implies this property of vector space does not hold. So this one is not a vector space. This means it is false. Is it okay? Any doubt or any comment or any other, maybe some other properties may not fail, may not fail. So anyone check any other property that is not, that doesn't hold in this case? Anyone other than this property? Have you, how many of you solved this one? Arvis, have you solved this question?
yes, sir. Like I just wrote that the identity for the field is half of half of, and for any vector, one dot a is not equal to a, so it's not a vector space.
And others, have anyone else solved? Means this is the, just for now, just take homework type thing. Means is this only this property doesn't hold or any other property other than this one? Please check this one. Is the only this property doesn't hold for this case, or you have more properties? And for one more interesting question, you can see in this case, you already know, means if you take even order, then it is possible or not, because you say for odd order you get 0 eigenvalue, for even order maybe exist, may not, means there is possibility you will not get 0 eigenvalue, but there is also possibility to get 0 as eigenvalue. Okay, now for question number 9. Yes, anyone?
Taking trace on both sides, you can prove it.
Yes, the simple one is that is trace of ABVA equals to trace of I, and this will become 4, this becomes trace of AB minus trace of BA, and this will become 0 equals to 4, which is not possible. If this happen, then this implies this one, and this implies this implies this, and this is not correct. This is a contradiction, which is not possible. 0 equals to 4. So this one is false. So in this case, you have to state two results. Trace of A minus B equals to trace of A minus trace of B, and one is that trace of AB equals to trace of BA. These two results has been used in this. Means trace of, if you get two matrix difference, then trace become difference of that matrices. And this one is that AB and BA, already you proved above that they have same eigenvalue. Means same means if it has 0 eigenvalue, then it is 0. If you non-zero, then 0. And then non-zero matrix, that is also eigenvalue of AB, then eigenvalue of BA. So from there you can also say this result will hold directly, that trace is the sum of eigenvalues. So if eigenvalues of A, B and B are same, then the trace is also same. Otherwise, you can just take the product. AB means trace means diagonal element, sum of diagonal elements. So diagonal elements of AB and diagonal elements of BA both are same. You can approach from that one. So you can state this result from there. So yes, anyone has any doubt or any comment overall? Other than this one, that the Suman has stated that this paper was a little bit lengthy. So how much extra time you need for this paper to solve completely? Yes, Suman?
Can you repeat once?
Means you say the paper was lengthy, so
Yes.
I want to know how much time do you need to solve this paper?
Actually, if I need to give a proper justification for each question, then maybe 40 to 45 minutes.
Means 10 to 10 minutes more approximately. No?
Yes, 10 minutes more.
Yes. Anyone has any means other than yes? Money says okay, 5 to 10 minutes.
So it's like you can give the time for the paper to be this, and then the submission time to be 5-10 minutes more. Like in the 40 minutes, we have to first see the paper, then we have to spare 5
Yeah,
minutes at the
actually,
last for the scanning also.
yes. Yeah,
So we're left
professor
with
has
30 minutes only.
yes, professor has actually constructed this paper for 30 minutes, 30 plus 10 actually, 10 minutes for uploading. But you can upload the question paper in 5 minutes. You can take time, but for professor's point of view, it was 30-minute paper. So you have to get only 10 minutes extra, then you can easily solve. And questions are easy, might be. That's why the professor has put less
Yes,
time.
question were really easy, but time was short, so I made some mistake also. So.
Yeah, that happened when you do that. Yeah,
Yeah, so
anything
like the
else?
fifth question, it took a little more time as compared to like
Yeah,
the 30
fifth one
minutes
is
provided.
actually, yeah, this one I think I alone take 5 minutes if you do properly.
Yes, sir. So if
At
it is
least
in 2
and
plus 2, then it's okay. But
yes,
for 1 plus 1, it took a lot more time.
yes. Yeah, this one is actually lengthy one. Other one is little bit means just okay for 2 minute question. Okay, anything else you want to comment or anything? And maybe today or tomorrow assignment will be sent. So just let me recall that assignment is for 15 marks. And I have suggested, sir, that maybe he put a lot of question from books exercise. So you have to solve some questions selected by some question I have selected from the books and some questions professor has decided to give you as an assignment, and maybe some definitions and all other things. So final today or tomorrow you will get your assignment to submit. Okay, anything else?
So how much time will we get to complete the assignment?
You will get sufficient time, at least 10 to 14 days you will get.
Okay, sir.
So
And the like the questions from the book access will be up to what we have studied till now.
no,
Or
maybe
it will
other
get
than
the
that.
future also.
Yes, maybe
Okay.
you haven't read, so you have choice. You read from books, you do from internet search, and all that things. You can discuss between yourselves to how to solve this question or that part. So that's why it is given enough time. I think 10 to 14 days
Okay.
time it is given. So you have to do around yourself comfortably. Yes. Anything else? Any comment or anything? And there is one day last lecture was not recorded due to some technical or maybe something. I also seen in the last that it is not recorded lecture.
Sir,
So
can
okay,
you explain first question again?
first question.
Yes.
Yeah, okay, let me explain. First question. Yeah, this one is just beautiful. This transformation is of 3 cross 3 matrix, 3 cross R3 to R3. So this implies that matrix of T is of 3 cross 3 order. This implies characteristic polynomial of t has 3 degree 3. This implies real eigenvalue. So let's say lambda is the real eigenvalue of t and v is the corresponding eigenvector, and v corresponding vector means v is not 0. Now take w equal to span of v. So it is one dimension, null subspace. It is done because v is not 0 and is spanned by one vector. Now we have to show tw equals to, tw is contained in w. So if you take any w in w, it is of the form w equals to kv for some scalar k. Now you put tw, you get t of k of v. Okay, then you have to do it k t of v, you will get k lambda v, and this is again scalar. It is linear combination of v itself, single. So this implies t of w is in w, and w is an arbitrary element we have taken. So this implies tw is contained in w. This implies w is t invariant subspace. Is it okay?
Okay, sir.
Yes. So if anyone has any doubt or anything, then ask. Otherwise, we can now end here our meeting. Okay. So thank you, everyone. Now everyone can leave the meeting.